All right? It's going to start right at 9 and end right at 9:15 every time. So, if you guys are here right on time every time, then we never have to go over. All right? Now, who was in the class last year?
I couldn't
So
stop.
Two years ago.
Some remember, some don't. Or, yeah, 2 years ago. Some remember, some don't. But that's okay. We're going to teach it in a way, hopefully, that those who remember can gain from it, and those who don't, hopefully, won't be left behind because of the way that we organize things. Chemistry is the study of how matter, and that just means stuff, interacts with each other.
Liquid
Okay?
gas.
How stuff interacts with each other. Okay? So, let's say this is some stuff. Here it is. Stuff A. All right? There's some stuff. Okay? Here's some other stuff. B. All right? And I want to see how that stuff interacts with each other. Okay? Now, a lot of you know some chemical reactions. You know that if you put vinegar and baking soda, it makes a little volcano. You know that if you put gasoline in a car, it makes the car go forward. You know if you put food in your body, it gives you energy, right? So these are all chemical reactions. So one way to kind of show that these have chemically reacted is to draw this sort of a thing, where we have one of these coming together with one of these to form a new thing. And the new thing we'll say is a combination. We'll call it AB. Does that make sense? So we formed what we call a bond between A and B. Does that make sense? To form AB. Now, I can draw a little picture of this. Let's draw a little picture of this down below. Here's a little container, and it has some A's in it. There they are, correct? Here's a container down below here that has what in it over here?
B's.
B's. I'll draw a little A and a little B here. And then I pour them together in a larger container. I'll make these little X's, okay, so they're a little bit different. And then it forms these things, X's with little dots by them. Do you get it? You see how that works? We're mixing A and B to form, what is this over here?
AB.
AB. Does that make sense?
Yeah.
Now, the important thing to recognize here is that for every A that goes in, if I put one A in, how many B's do I need? One. And if I put one A in and one B in, how many ABs do I get? One. Does that make sense?
Yeah.
So, we call this, we give it a fancy name. All right, a fancy name. The fancy name is stoichiometry. Stoichiometry. Can you say that?
Stoichiometry.
Stoichiometry is the measurement and monitoring of the number of reactants. These are the things that are reacting, right? They react together to form this, and this we call the, what do you think?
David, you can see.
No, this is the reacting part. These are reacting together. This is called the,
Reaction.
nope,
Evolution.
nope. What do you think, Sam? Product, that's right. This is the product over here. This is our product. Okay? These are called the what?
Reactors.
Reactants. Reactants. A single, and that's S means two more of them, right? This is a reactant. These are reactants. Can you say reactant?
Reactants.
It's going to what? React. The things that are going to react. And this is the product. All right, so the reactants and the product. And monitoring, now I didn't write how many of A's I have, right? But when I don't write anything, it's just the same as saying there's one of them. Does that make sense?
Yes.
How many B's must there be? One. And how many ABs do I get?
One.
I don't get two?
No.
Why don't I get two?
Because you're mixing. It's one substitute. It's one.
All right, so one of these is coming together with one of these to form one of those, right?
Yeah.
Does that make sense?
Yeah.
So don't get confused into thinking that I should be doing 1 + 1 = 2. Because sometimes people say that. Wait a second, you're putting 1 + 1 together, why don't you get 2 at the end? And you can say, no, we're not adding these things, we're reacting them, and they form a new thing, right? And that's a very important thing to recognize, okay? So I have some toys that I'm going to help us kind of think about this with. All right? What? 1, 2, 3, 4. What are they?
Legos.
But what all kinds of Legos. What are they made into? They're spaceships. That's right. I made some spaceships. I have 4 spaceships, right? Can these spaceships fly?
Yes.
No. What are they missing? They're missing the pilots, right? They need the pilots, okay? So I have 4 spaceships, right? But I have no pilots, okay? When I combine my 4 pilots, here's 1 pilot, 2, 3, 4. When I combine these 4 pilots with these spaceships, then I have 4 working fighters, right? They can go off and fight. Does that make sense?
Yeah, I want the clothes super.
So, should I put a 4 in front of here?
Sure, yeah.
And a 4 here?
Yes.
And a 4 here?
Yes. No. No.
Yes.
Yes.
Oh, except
Yes.
4 of the
4 spaceships plus 4
Pilots.
pilots equals 4
working spaceships.
fighters, right?
Yeah.
Working spaceships. Okay?
Yeah.
Now look. This is what I have here. But when I write a chemical equation, I don't need to put 4 and 4 and 4. Because all I'm showing is that I have 1 spaceship coming together with 1 pilot, but it's just happening a lot of times. Does that make sense? So this can be stated in a simplified way. Just again, for every 1A that you have, for every 1 ship that you have, you're adding a pilot and you're getting a working spaceship. Does that make sense? So when I just draw A plus B plus AB, it doesn't mean that there's only 1A and 1B. There could be a million or a billion of these combined with a billion of these to make a billion of those. Does that make sense? But this is just the simplest explanation of what's occurring in these containers. Correct? Again, I have these containers of A, B, and I'm combining them together to form these combinations. But I don't need to say, oh, I have 400 billion of these and 400 billion of these, and I'm making 400 billion of those. I can just simply say, this is what's occurring. For every 1 of these that's coming around, I'm getting 1 of these and 1 of those. Does that make sense?
Yes.
Now, what if I add in another pilot? Am I going to get more working spaceships?
No. You need a spaceship.
I need a spaceship, don't I? I just have an extra pilot. So I really didn't, he didn't, what? He didn't react. He didn't react, correct? So, I can say, what happens if I put 3 A's in and combine it with B's? How many ABs am I going to get? I'm still going to be only stuck with 1 AB. Because why? Because I only had a B. I only had 1 B. So this one was what we call our reactant that was limiting the process. It was stopping the process from occurring. Correct? Because as soon as it ran out, then what?
You couldn't make it anymore.
I couldn't make it anymore. Does that make sense? So, limiting reactant. Or you can call it the limiting reagent. Reagent is another way of saying a chemical. All right, so looky there. We have some stoichiometry. Now,
Geometry.
have you guys ever seen an F-16 fighter?
Yes.
This is an F-16 fighter. It's special because it doesn't just need a fighter or a pilot. It also needs a gunner. Or some people call it the navigator. Does that make sense? If all of these are special F-15 pilots, how many ships am I going to get?
2.
But I have 5 pilots.
But what's the last one?
Yeah.
You're still gonna get 2 because there's not enough.
Does everybody see that? So now, if this is A, B, but for every A there's, I'm going to draw it like this for a second. Every A that I have, there's 2 B's stuck on it. Ship, what's this? Pilot, and the result is a ship with 2 pilots on it.
Wait, isn't it 2 pilots? Wouldn't you have to write a 2?
Yeah, so now I have to include a 2 there. And do I put a 2 here now?
No, it's
No,
no.
this
So
is
there's one ship.
One ship with 2 pilots.
3A plus B equals
Now,
B with 3A.
another way of saying this, see this, I have this drawn like this.
A plus B
A
equals.
with 2 B's on it. Another way of doing that is just saying A, B, and then putting a little 2 down there to show that I have 2 B's. Whoops. Okay?
On fire, Pilot. Pilot, you fired. Fire, Pilot.
One is home.
Okay?
Two of them fired.
So, what does this little 2 mean?
Two
I have 2 B's for every A. Correct?
The other way to say A, little
What would this mean? What would this mean? A, 2, B.
2 A's and 1 B.
2 A's for every B. Does that make sense? Now, now we have the ability to identify lots of different combinations. So if I say x2, y3, right?
There's 2 X's for every 3 Y's.
2 x's. How many y's do I have, little ones? 3. That 3 corresponds to that y there. Does that make sense? That's one way to think about it. But you don't take 1.5 of stuff usually, right? Okay? So, these are chemical formulas that tell us the ratio of the different, what we call the different elements in the compound. Okay? So a word compound is what we use when we're talking about the whole thing. These are different elements within there, and these numbers tell us how many. Correct?
Correct.
All right. So, how much time's left?
3 minutes.
3 minutes. So if we have a chemical reaction where 3 O's come together with 2 X's, what will the product of this reaction be? Okay. O, 3, X, 2. Did you see that?
So that's why CO2.
How did we get that? 3 O's, oxygen, and there's 3 of them. 2 X's, X's with 2 of them.
CO2, carbon plus 2 oxygen.
Okay? Does that make sense? You see that ratio, how that works? All right, I'm going to give you another one, and you tell me what the products are. I'm going to give you some reactants, okay? Here's A. It combines with 2 B's and 3 C's. What are my reactants? Or what are my products? C3, correct? Just like that, right?
So you're just putting all
These numbers in front are going down below.
So, like CO2 for carbon
Okay,
dioxide.
so here's another scenario I'd like to ask you, okay? In my pocket, I have one of these. Okay, here it is. X2, Y3, H7. I have that in my pocket right here. If I break this up into all of its elements, how many X's am I going to have in my pocket?
2.
2. Does that make sense? Because if this breaks up into its elements, if it decomposes into its elements, I'm going to have 2 X's, 3 Y's, 7 H's. Does everybody see that? All right, excellent. Here's another one. In my pocket, I have X2, Y, Z, 3. But I have 4 of these in my pocket. How many X's do I have in my pocket if I break it all up?
8.
Okay, each one of these has how many? 2, but I have 4 altogether. Does that make sense? So 2, one time, 2, a second time, 2, a third time, 2, a fourth time, 1, 2, 3, 4, 5, 6, 7, 8 of the X's. Does that make sense?
1
Yes.
minute. 1 minute.
Okay, so this is all called stoichiometry. Stoichiometry. Okay? Stoichiometry. Now, let's try one more. In my pocket, I have 14 Z's. In my pocket, I have 14 Z's. But these Z's are complexed with a molecule. It's this kind of a molecule. H2Z4, H2Z2. H2Z2. So how many molecules do I have in my pocket?
4. 18. 28.
In my pocket, there are 14 Z's. But all of those Z's are complexed up
56.
with these molecules?
7.
How many of these molecules?